All right, if we're using the function notation in order to apply it to problem solving, we can see that in lesson 2 and 3 we solved problems about relations defined by an equation, and now we're going to use the function notation we've used in the last 2 lessons. So, we're pulling from the example in lesson 3 where we had the following scenario. A candle manufacturer found their long-last candles melted according to the formula H is equal to negative 2T plus 12, where H is the height of the candle in centimeters after T hours. The relation between the height and time is described by an equation. This equation right here. The relation is a function because for each input there's only one output, which means that I can put it into my function notation. If I do it in function notation, because the value of h is dependent on t, I'm going to change h to h as a function of t. In this example, the notation h as a function of 4 is a simplified way of representing what is the height of the candle after 4 hours has taken place. So, if we're looking at the problem, a candle manufacturer found their long-last candles melted according to the formula H as a function of T is equal to negative 2T plus 12. Use a graphing calculator to sketch the graph of the function and show the graph on the grid. Well, what I'm actually going to put in my calculator is y is equal to negative 2x plus 12 to graph it out. I know that the x and the y can't be negatives, so I'm just going to deal with it if it is positive ones, like we see on the graph here. Then, when I'm graphing it out, well, I'm going to say that the vertical is actually going to be represented by h as a function of t, and the horizontal is going to be represented by t. I'm going to graph out approximately what this is going to look like, and I'm going to say that the vertex, well, this is going to be at the point of 12, and this is going to be at 6, and there's my two intercepts. Those are the two maximum values that either h or t can possibly be. If I am determining the value of h as a function of 5, then I would say that h is a function of 5 is going to equal negative 2 times 5 plus 12, which would equal 2. If I'm writing in words what the meaning of h is a function of 5, it is the height of the candle after 5 hours is 2 centimeters. If I'm evaluating the rest of these, well, h as a function of 0 is going to equal negative 2 times 0 plus 12, and that's going to give me 12. That would be the starting height of the candle. In the second case, h as a function of 6 is going to be negative 2 times 6 plus 12, which is going to be 0. That is going to be after 6 hours. The candle is melted. And for the last one, h as a function of 8 is going to equal negative 2 times 8 plus 12, which is going to give me negative 4. And I'm going to say that this one has no meaning because a negative height is impossible. So it actually means nothing in the context of the question. How long will it take for the candle burn down to a height of 7 centimeters? Well, I can say that if 7 is equal to negative 2t plus 12, then I'm going to subtract 12 from both sides and say negative 5 is equal to negative 2t. Divide both sides by negative 2, and I'm going to say that 5 over 2, or 2.5, is equal to t, which means that how long does it take? It takes 2.5 hours. If I'm suggesting an appropriate domain and range, well, the domain is going to be represented by t, and 0 is less than or equal to t, which has a maximum of 6 in this case, where t, e, r. The range is going to be represented by h of t, where 0 is less than or equal to h of t, which is less than or equal to 12, where h of t can be every real number. And that's it.